Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 18, 2025, about 5 days ago. It introduces the first benchmark for long-term, low-contrast periodic human workflows and a lightweight training-free method that actually beats powerful zero-shot large language models at detecting and tracking these repetitive routines. The paper is titled, Unsupervised Discovery of Long-Term, Spatiotemporal Periodic Workflows in Human Activities. And as we will see later, the results are not just academically neat, they really matter for practical monitoring of complex human tasks. Alright, Figure 1 makes the core idea very concrete with a yoga routine. The top row illustrates a short-term periodic activity, where each pose maps cleanly to a small set of tokens, and the repeating pattern has very high contrast, so periods are easy to count. The bottom row shows a long-term workflow, where many more distinct tokens and branches blur the pattern, creating a low-contrast, multi-step cycle that is much harder to detect automatically. So while Figure 1 contrasted short and long cycles conceptually, Figure 2 maps out what the benchmark actually contains. The panels on the left illustrate raw sequences and trajectories for body pose, hand pose, indoor paths, and outdoor routes, showing that workflows span very different sensing setups. The charts on the upper right summarize how 580 sequences distribute across 4 modality types and a wide range of period lengths. The schematic on the lower right then explains the 3 evaluation tasks: unsupervised period boundary detection and counting, completion tracking from partial observations, and anomaly detection in one period of a repeated routine. While Figure 2 laid out what the dataset contains, and Table 1 now clarifies how the main benchmarks differ conceptually. Table 1 shows that only the new benchmark simultaneously includes explicit periods, full workflows, and purely unsupervised learning, whereas SPAD and single-period activity segmentation rely on supervision. Table 2 then compares concrete datasets, revealing that the new benchmark has far more multi-branch workflows and uniquely supports unsupervised period detection, completion tracking, and anomaly detection all at once. Okay, while the tables compared benchmarks and datasets, Figure 3 walks through how the baseline actually discovers workflows. The top panels turn soft tokens into a 2-dimensional activity transcript, then use a 2-dimensional fast Fourier transform with dynamic time warping scores to pick an initial period window. The lower panels convert hard tokens into repeated segments, compress them, and align them with the multiple transcript alignment algorithm, which reveals a multi-branch workflow and precise period boundaries. Alright, Table 3 reports how different unsupervised methods handle the 3 tasks, and the left half shows that traditional periodic and anomaly detectors perform very poorly compared with the proposed baseline. The baseline achieves far lower period counting error and much higher temporal overlap, while also running faster or comparable to large language models like GPT-4 and Gemini 2.5. The right half presents ablations, which reveal that soft tokens plus window size re-ranking and a 20% buffer give the best mix of accurate period detection, precise completion tracking, and strong anomaly localization. So to wrap up, the work does 2 big things. It defines a realistic benchmark for long, messy human workflows, and it shows that a simple, training-free pipeline can reliably detect periods, track progress, and catch anomalies. That opens doors for low-cost monitoring in factories, sports, and healthcare. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.